Hello and welcome to this video for basic sentential logic, informal fallacies, and cognitive biases. This video corresponds roughly to material that shows up in sections 3.2, 3.3, and 3.4 of the text. And in particular, I'm just going to do a few examples of proofs that use all of the inference rules so far. And not only am I going to work through some examples of proofs that use all of the rules, but also talk about a strategy for approaching proofs. So far, when we've been doing a proof, we've just been given the premises, conclusion, and then just looked for places where we could apply rules and essentially hope that eventually we get to the conclusion. And often that's totally fine, but it's not the only way to go. So here's a proof. And what I've done here off to the side is I just have all of the six inference rules here. I've mentioned this already in previous videos, but I'll mention it again now. I don't really recommend trying to just memorize the rules with flashcards or just looking at a list of the rules and trying to memorize them. It's not a waste of time, and I don't think it's pointless, but I think there's a better way to do it, which is kind of what I'm doing here. I'm just going to have all of the rules right next to me while I'm doing the proofs, and I'm just going to consult them as much as I want. So you could just have a sheet with all of the rules next to you as you're doing proofs. And as often as you need to look at them, look at them. And you'll just find over time that you're looking at them less and less, because as you use them, they sort of get ingrained in your brain. And the reason that's more efficient is because not only are you memorizing the rules, but at the same time, you're getting good at doing proofs. Okay, so with this proof, I said I was going to talk about a different approach or a different way of doing them. And in this case, what I'm going to do is sort of work backwards. So I'm looking at this proof and I'm thinking, okay, the conclusion is not K. What that means is that the last line of my proof is going to be not K. And I don't know what number that's going to be because I haven't done the proof yet. I don't know how many lines it's going to take me to derive K. So I'll just call this Z. This is just a variable for now. But I know this will be my last line. And so now I'm going to ask myself, if this is the last line, what would the second to last line be? How could I get K? Is there any way? Like what will line Y be? The line right before this. Well, if I'm looking up here, if this is not K, how could I get not K? Well, K is the antecedent of this conditional. Look here at modus tollens. It says if I have a conditional and I have the negation of the consequent, I can derive the negation of the antecedent. Well, not K is the negation of this antecedent. So if I had the negation of the consequent, I could use modus tollens to get not K. So that means that maybe the second to last line is going to be the negation of this consequent. And once I get this on line Y, whatever that is, the second to last line, I can use modus tollens on lines 1 and Y, whatever that is. I have a conditional. I have the negation of the consequent, so I can get the negation of the antecedent. So maybe this is what the last two lines of the proof will look like. Well, now my question is, how am I going to get L or R? What's my third to last line going to be like? I know by DI that if I could get either of these disjuncts by itself on this line here, I can just use DI to get the other disjunct. It's not clear how I could get R, but I can see how I could get not L. Okay, so it could be that my third to last line is not L. I'll get not L or R by DI on line X. Just call this X. How can I get not L? Well, by DS here. I have a disjunction, so here's DS to remind you. If you have a disjunction, you have the negation of one of the disjuncts, you can derive the other disjunct. Here I have a disjunction. This is the negation of the second disjunct. So by ds, I can get this disjunct, not L. So this would just be lines 2, 3, ds is how I could get L. So you can see what I've done here is I've sort of worked backwards until I made contact with the lines I already had, in this case the premises. Now I know how to do the proof. Okay, what I'm going to do is first do ds to get not L, do di to get not L or R, and then do modus tollens with this and line 1 to get not K. So now I'm just going to erase that. If you're actually doing this on paper with a pencil, you can use another sheet or use some scratch paper to work backwards, or if you want to erase, you can do that as well. But I know what I'm going to do. Now I'm just going back in real time forward ds on lines 2 and 3 to get L. I have a disjunction, negation of the second disjunct, so I derive the first disjunct. Now that I have not L, I can get not L or R by di on line 4. This is the negation of this consequent, so by modus tollens I can get the negation of the antecedent. Antecedent is K, negation is not K, and that's by lines 5, 1 modus tollens. So now I've just walked forward exactly the same steps that I realized I was going to have to produce when I went backwards. Let's do another one. This one has 4 premises. I'm trying to get A and B. Now here I'm thinking, well, A and B doesn't just show up here like that conjunction as the consequent of a conditional. So I could just use modus ponens to get A and B or something like that. So right now I'm thinking what I'm probably going to have to do, if my last line is A and B, it could be that the way I get that is that I independently derive A somehow, and then I also independently derive B somehow, and then I just conjoin those. Right, so I don't know, again, what this last line will be, how many lines it'll take. Call it Z, call this Y, call this U. These are just placeholders. But eventually, once I derive A and once I derive B, I can conjoin them, lines U and Y conjunction, to get this. So now I can wonder, okay, how will I get A, and then how will I get B? How might I get A? Well, A shows up here. If I could get this antecedent, then I could do modus ponens to get A. So it might be that the way I get A is by managing to derive this and doing modus ponens on lines T and 1, because this is this antecedent, then I could get A. Now, of course, I say one way it could happen, because when you're working backwards, sometimes there might be more than one way to get it, or the first idea you try may not work. In this case, it's going to work, I know, because I've already made these slides. But be prepared to ditch a plan and start over with a new plan. In this case, it'll work. How might I get this? Well, it's a disjunction. If I could get either disjunct by itself, I could use di. Can I get other disjunct? I don't see this anywhere, but I do see M right here. It's this second conjunct here. So what I might do is simplify M and then get M or this by di on line S. So now I've sort of traced out the steps I need to get A. First simplify M, do di to get that, and then modus ponens to get A. What about B? Looking up here, B only shows up here, and it's not B. So I'm thinking, hey, this is a conditional. If I could use modus tollens on this to get the negation of the antecedent, the negation of that antecedent would just be B. What I would need is the negation of the consequent. Well, the negation of the consequent's not N, so I would need N. Is there any way I can get N? Well, here's N. Well, actually, first off, let me just write down what I came up with here. If I could get n, then I can do modus tollens on line x and 3. I have n, that's the negation of the consequent, so I can get the negation of the antecedent b. Now, how might I get n? Well, if I can get this antecedent r and a, I can get n by modus ponens. So maybe I can get r and a and then just do modus ponens on this line w and line 2, r and a, to get n. How might I get r and a? Well, here's a, and there's r. So if I can get r here, then I can just conjoin that with a to get r and a. So that would be lines uv conjunction. And how could I get r? Simplification on line 4. So again, you can see what I've done is I've sort of worked backwards to figure out strategically how this is going to work before just jumping in. Now this was artificially clean, and the reason is I did this proof beforehand and I knew exactly where to put these, lines. In real life, you don't know how long it's going to take. You don't know if you should derive b first or a first. In this case, my derivation for b required that I already have a because I needed to get this conjunction. So you may have to try a few different ways of going about it, but you see the strategic angle here. Now, I'm just going to erase these and put all of the steps in normal order. So if you recall, the first thing I'm going to do is I'm going to simplify m from line 4. Now that I've got m, I can do di to get m or j, and if j, then not j. That's by di on line 5. I did that because this is the antecedent of line 1, so by modus ponens, I can get a. And that's one of my conjuncts here. So I've got a. Now I want to try to get b. Remember that I'm going to simplify r from line 4 so that I can get r and a by conjunction on 7 and 8. And the reason for that is that now I have this antecedent. I can get n by 2,9 modus ponens. Now that I have n, I can do modus tollens on line 3. I have the negation of the consequent, derive the negation of the antecedent, so I can get b by 10,3 modus tollens. And now I have a and b. I have a on line 7 and b on line 11. So I can just conjoin those, a and b, and the proof is done. Okay, let's do another one. Now this one I'm not going to work backwards. Let's just work forwards and see what happens. So what are the things I can do here? This is a conjunction, so I could simplify either of these conjuncts off. I don't really have what I would need to do modus ponens or modus tollens with either of these conditionals. 4 and 5, I could do a disjunctive syllogism. I have a disjunction, I have the negation of one disjunct, so I could derive the other disjunct. So the three things I could do right now are ds on 4 and 5, or I could simplify either of these conjuncts off. And it looks like right now those are my only options. I'm going to go ahead and simplify this second conjunct. And the reason is that I see that this is the antecedent of that conditional. So now if I simplify this off, I can do modus ponens to get if h then r, which I'm going to do in a minute. First, though, I'm going to go ahead and do my ds here that I spotted that I could do. I'm going to go ahead and do that. Now I'm going to do the modus ponens on 6 and 1. This is that antecedent, so I'm going to get if h then r. And you'll see I'm just applying rules. So this is the other strategy. If you don't want to work backwards, or you try working backwards and nothing works out, you can always revert to the original strategy of just apply the rules any rules you can and see if something interesting happens, something helpful. What can I do now? Well, I've got something else I can do. I can simplify this other conjunct off, so I can get not R. Now there's a few things I could do. I could do modus tollens on 8 and 9 because that's the negation of that. But now I've got a lot of pieces here. I've got a lot of things I've derived. So now I'm going to sort of take a step back and try and figure out, okay, what can I do? Can I work backwards now? How could I get not J? Well, if I could get H, then I could get not J by modus ponens. Is there any way I can get H? This is equivalent to H. So many of you will look at this and go, well, H or H, that's equivalent to H. So you ought to be able to use modus ponens here. That would be a truth-preserving rule. If we had a rule that was kind of like modus ponens, but it was, if you have a conditional alpha then beta, and you have a disjunction, which is alpha or alpha, then you can get beta. That would be truth-preserving rule. But we don't have that rule, so we can't really do that. There is a rule called duplication that would let us go from H or H to H, but we don't have that rule yet. Is there anything else we can do? Turns out there is. How could I get H? Well, another way I might be able to get H is if I had, because notice H is, let's say, the second disjunct here is H. If I had the negation of the first disjunct, I could get H by ds. Right? Is there any way I can get the negation of this disjunct? Is there any way I can get not H? Sure enough, by modus tollens, I can get not H right here. So I have a conditional, I have the negation of the consequent, so I can derive the negation of the antecedent. That's not H by modus tollens on 9 and 8. Now, I have the negation of, let's say, the first disjunct. Don't worry, some of you are looking at this thinking this is kind of weird, and I'll get back to this in a minute. But this is the negation of the first disjunct, so by ds, I can derive the other disjunct. Right? So let's look at ds. If I have a disjunction, if I have the negation of one of the disjuncts, I can derive the other disjunct. I have a disjunction, I have the negation of one disjunct, I can derive the other disjunct. So I can get H by ds on 10 and 7. And now that I have H, I can get not J by modus ponens. Okay. Now let's go back to this one. There's a couple of things here that you might be questioning. One is this H or H move I did where I used ds. If you look at ds and you look at the written schematic here, these are two different statement variables, and in many cases, a lot of students think incorrectly that because these are two different variable letters, alpha and beta, these have to be different statements. And they don't. Alpha is a variable, that could stand for any statement, and beta is a variable, that could stand for any statement. And nothing rules out that they could be the same statement. And this is true of variables in general. So when you're doing, math in 5th grade or junior high or whatever, and you learn the formula for the area of a rectangle, that's height times width, h times w. Well, it could be that h and w both stand for the same value, right? They could both be 5, and the area would be 5 times 5 is 25. So just because you have two different variable letters like h and w that stand for height and width doesn't mean they have to correspond to different values. So alpha and beta are different variables, but they don't have to correspond to different statements. And they're not. Here it happens to be the same statement. This is one place where the verbal expression of the rule is a little more clear, because when I describe the rule verbally, I say, if you have a disjunction and you have the negation of one of the disjuncts, you can derive the other disjunct. But that verbal description of the rule is, while completely accurate, notice it didn't say if you have a disjunction and the two disjuncts are different statements. That was not specified in the rule, and the reason is that it doesn't have to be specified. It works fine even if they happen to be the same. And you can also tell that it works. One reason that's fine is that's still truth preserving. Okay. The second question you might have is, look here, we managed to derive both a statement and its negation. And you might think, that looks fishy, Rick. And in particular, you might think something like, hey, Rick, I thought our rules were truth preserving. That was like a big deal that you talked about, and now it looks like somehow we managed to derive statements that are inconsistent, or we derived something that has to be false. We don't know which one of these is true and false, but we know one of them is. Okay, if H is true, not H is false, and vice versa. So somehow we managed to derive something false. But I thought the rules were truth preserving. How could we do that? How could we get a contradiction, or how could we get something we know is false? Well, here's the way to think of it. The rules are truth preserving, but what does that mean? It means that if the statements we're applying the rules to are all true, they guarantee that we will only produce true lines. Well, what that means is that if we manage to derive something false, then because the rules are truth preserving, the stuff we were applying those rules to can't have all been true. And so in particular, what it means is that these premises are inconsistent. There's no way these are all true. And that's the only way we would be able to derive something false using truth-preserving rules, is if we weren't applying them to true things to begin with. It turns out that's okay, and I'll talk about that later. But the point is that in order for the proof method to work, you don't need to assume that these are consistent. What you need to do is just apply the rules correctly and derive the conclusion, and you're fine. Okay? So that's it for this video. In the next video, we'll be introducing the technique of conditional proof. But do a lot of practice. And in this video, I did some proofs that were a little more complicated. There were a lot of premises, and they took 7, 8, 9 steps to do the proof. Start simple when you're doing practice. There's a lot of practice problems online. If you find yourself having difficulty, it's not necessarily that you don't understand proofs. It's that you're trying to tackle proofs that are too hard initially. There's lots of them that are super easy. Go back to those to make sure you've got the basics down, and then slowly ratchet up the difficulty. The majority of the time when students come in to my office hours and say they don't get proofs, or they're having trouble with proofs, they are just trying proofs that are too hard, and often they're also going too quickly. So slow down, do slower proofs, and then over time the speed will just come naturally, and your ability to do more complicated proofs will just come naturally.